Hi everybody, my name is Arya and I'm from TerraUnity team. Today I'm going to show you how to create a scene based on a custom graph instead of our pre-made templates. So first you have to open TerraWorld Lite from the tools menu, and then you have to search the location that you want to generate. After that, select your desired coordinates from the search result display menu. Now that the interactive map is open, I'm going to select the mountain area with vegetation and a riverbed or a valley next to it. As I look around, I think this location is going to suit our needs for what we're going to do. You can also change the size of the area by changing the size value at the bottom of the interactive map. In the previous video, I showed you how to create the scene using our pre-made graphs, which are called templates, like the stylized forest template, which you can see here. But today I'm going to show you how you can create your own unique graph. So first click on the custom icon next to the template icon. Now click on new in order to create a brand new graph. Click on edit icon in order to open the TerraWorld graph menu. Now I'm going to drag the TerraWorld graph menu at the bottom of the screen so you can see how the scene is created step by step as we move forward in creating and developing our graph. The graph system is based on a series of nodes which are connected between the start node and the end node. You can add new nodes to the graph by right-clicking on the graph screen. After clicking on real-world data from sources, the first node, which is called TX real-world source, is going to be added. This node is our first node and it has no inputs, it has only outputs. You can see its settings as I show you. And all these settings are mentioned in the documentation file for the software. The second node, which is our end node, is added after clicking on terrain from generators. This node is called TX terrain and you can see its settings. Since TX terrain is our end node, it has only inputs and no outputs, unlike our first node, which had only outputs and no inputs. TX terrain has three roles. The first one is to generate the height map, the second one is adding terrain layers to the height map, and the third one is generating the background terrain for the main scene and the main terrain. For this video I'm going to turn off the background terrain since it takes some extra time to generate the background terrain. The first thing that you have to do after adding these two nodes is adding the Heightmap nodes. Heightmap nodes enhance the original height map, which is taken from the TX real-world source. The first Heightmap node which we are going to add is called Smoothen Terrain Process, and you can see its settings. Smoothen Terrain Process is used to reduce the sharpness of hills and mountains on the original height map. Now, one of the key settings of this node is iterations. Iteration shows how many times the smoothing operation is going to be done on the original height map. Meaning if the value is higher, the amount of smoothing which is going to be applied on the terrain is going to be higher than the original value. We are going to change the iteration value from 1 to 2 for a little bit more smoothing operation than the original 1 value. Now, if you pay attention to the Smoothen Terrain node, you will notice that both the input and the output of the node are height maps. Meaning the node will receive a height map, smoothen the height map, and the exit and the output of the node will still be of height map type. If you pay attention, you will notice that the input of the Smoothen Terrain node is from height map type, and TX real-world source node provides that height map. So I'm going to connect TX real-world source height map to the Smoothen Terrain height map. What this means is Smoothen Terrain node will receive the height map from TX real-world source, it will smoothen the height map, and the output of this node will also be a height map. The second height map node which we are going to add is called Trace Process. Trace process is used to add horizontal lines and traces to the actual terrain. With trace filter, there is one more thing which you need to do. Open settings, then advanced settings, and then click on auto set points. What this option does is it automatically sets the points for the trace lines which are going to be placed on the actual terrain. Or you can manually set up the lines by moving the dots around. Since the input of the trace filter node is from Heightmap type, we are going to connect the Heightmap from Smoothen Terrain to trace filter. What this means is the traces are going to be applied on the Heightmap, which is a Smoothen by the Smoothen Terrain node. Now the third node which we are going to add is hydraulic erosion process. Hydraulic erosion process is used to simulate the effects of rain and water on the surface. What we are going to do now is connect the trace filter output Heightmap to the inputs of hydraulic erosion filter. What this means is, after the traces are applied on the Smoothen Heightmap, hydraulic erosion filter is going to be applied on the Heightmap. Since these are all the Heightmap nodes which we are going to add for today, we are going to connect the output Heightmap of hydraulic erosion filter to the input Heightmap of TX Terrain. What this means is TX Terrain is going to generate the Heightmap after 3 different functions are applied on it. It is a smoothen first, and then the horizontal lines are added to it, and at last water and rain effects are applied to it. Now all you have to do is click on the generate button. Before continuing the video, I want to mention that we have recently established our Patreon page. And if you have enjoyed our solutions, become a patron of TerraUnity and support the hard work and dedication of our team. All of our patrons will receive a Discord role in our server, which can be seen by thousands of our community members. As soon as you click on the generation button, the process is going to begin. The generation time varies based on the size of your selected area, so please be patient. As you can see here, this is the raw Heightmap without any colors or terrain layers on it. Now we are going to add terrain layers on the Heightmap, and this is how you can do it. For adding terrain layers to the Heightmap, first you need to specify on which areas of the Heightmap the layer is going to be based on, and this is done by using masks. The first mask which we are going to use is called slope filter. Slope filters are used for creating masks of certain slope ranges on the terrain based on the degree ranges. Since the first layer which we are going to create is soil, our slope range is going to be between 0 and 20 degrees. Now if you pay attention to the slope filter, you're going to notice that the input of the mask is from Heightmap type and the output is from mask type. Meaning the node will receive a Heightmap and the output of the node will be a mask of a certain area on the Heightmap. For the inputs of the node, we are going to connect the output of the last Heightmap node to the mask node input. This means that the final Heightmap, which has gone through all the operations done by the Heightmap nodes, is going to be used for the mask. By connecting the last Heightmap node to the slope filter mask, we are asking the software to create a mask of the area from 0 to 20 degrees from the generated Heightmap. Now we want to put the soil layer on the selected area. In order to do this, we need to use terrain texture nodes. The node which we are going to use today is Unity Terrain Layer to Terrain Texture. The input of this node is a mask which we have created before, and the output of the node is a terrain texture which is needed for our end node, which is TX Terrain. Now what we need to do is select our terrain layer. Since we have already created the mask, after selecting the terrain layer, all we have to do is just connect the output of the slope filter mask to the input of the node. Now just connect the terrain texture output of the node to the terrain texture input of TX Terrain in order to specify and define our first terrain layer, which is soil. Again, click on the generate button in order to generate the scene again. Each time this message appears, click on yes, recreate the terrain. Now as you can see, the generated terrain is two colors. One is the color of brown, which is the color of our soil terrain layer, which is applied on all the areas in the slope range of 0 to 20 degrees according to the mask. And any area which is not in that slope range is painted black. Since we want to generate a natural environment, we are going to add more terrain layers. Right now the software supports up to 8 terrain layers. Now we are going to add a grass terrain layer for vegetated areas. Just like the last terrain layer, we are going to add another slope filter. The slope range of this slope filter mask is going to be 15 to 33 degrees. Again, like the previous mask, I'm going to connect the output of the last Heightmap node to the input of the slope filter mask. For grass terrain layer, we are going to use another mask node which is called color filter. Color filter is a node which creates masks of areas covered in a certain color based on the satellite image. If you look at the color filter node, you will notice that unlike slope filter, it does not need a height map. It needs a satellite image. So we are going to connect the satellite image output of TX real world source node to the input of the color filter node. And the selected color is on black, and since we want to create a grass terrain layer, we want a mask of all the green areas in the satellite image. So we are going to change the color from black to green. I also changed the color tolerance from 20 to 50, so a wider range of green colored areas are included in the mask, not just a specific type of green color. For this terrain layer we have two masks, but the terrain layer node, as you can see for soil terrain layer, has only one input for masks. So we have to combine the masks into one mask. Here is how we are going to do it. In order to combine and include two masks, we have to use the mask mixer node. Now as you can see, the mask mixer has two inputs. So we are going to connect the two masks into the inputs of the mask mixer node. Since we want to include both of the masks, the blending mode has to be on OR. This means that any area which is in the slope range of 15 to 33 degrees and all the areas which are green in the satellite image are included in the mask, so grass terrain layer is placed on these areas. Since we have already specified the mask for the terrain layer, now we are going to add the Unity terrain layer to terrain texture node. As soon as we add the node, we connect the outputs of the mask mixer to the inputs of the terrain layer in order to specify the area which the terrain layer is going to be placed on. Just like the previous terrain layer, all that is left to do is selecting the terrain layer itself and connecting the node output to the terrain texture inputs of the TX terrain node. We can have 8 terrain layers, but today we are going to create 4. We have 2 terrain layers, so let's create 2 more. Let's create a rocky terrain layer. Again, I add another slope filter, and this time, since mountains and high slope areas are rocky, the slope range is going to be 33 to 90 degrees. And I connect the output of the last Heightmap node to the input of the slope filter node, just like the last 2 slope filter nodes. Again, we add the Unity terrain layer to terrain texture node and connect the mask output to the input of the node, and then select the terrain layer and connect the node to the terrain texture of TX terrain node. The last layer is flow layer. This layer is for water flow paths. Again, in order to create the terrain layer, we need to specify the mask, but this time we are not going to use a slope filter or color filter. There is a unique mask node called flow way to mask, which creates the mask for water flow paths. This node also requires a height map, so just like the previous mask nodes, we connect the height map outputs of the last height map node. Now there's no need to change anything in this node, so we just add the Unity Terrain layer to Terrain texture node and then connect the mask to it. As soon as we select the terrain layer, we connect the node to the terrain texture input of TX terrain, and that is our fourth and last terrain layer. Now click on the play button in order to generate the scene with all 4 layers applied on the height map. Now as you can see, the scene is generated with all 4 layers applied on the height map based on the masks which we defined. Now the height map is placed and terrain layers are applied on it, but the scene has no objects. In order to add objects to the scene, we need to use the scatter nodes from generator section. Our first scatter node is grass scatter. Grass scatter node places millions of blades of grass and flower plants for the entire scene dynamically, with the minimum performance impact if you set it up properly. First you have to select the material which you want to place on the scene, and then you can increase or decrease the density of the model in the scene by changing the density value. You can also change the scale of the model which is going to be placed on the scene from the scale settings. We are going to change the model type from quad to from mesh in order to show you a new feature which is added to the software. This new feature, which is for grass layers, is called Billboard layers. Now keep this feature in mind, and I'm going to show you what this means after we generate the scene and see the grass placed on the terrain in the scene. Now as you can see, grass scatter needs a mask for specifying on which areas the grass is going to be placed on. We can create a new mask for this node, but there's no need to do this, because we already have a grass terrain layer and we can put the grass on our terrain layer. This means that the grass is going to be placed on all the green areas of the scene. Okay, now let's generate the scene. Now the scene is generated. Let's view the grass which is placed on the scene. And by the way, if you want to be able to see the grass from farther distances, you can increase the rendering distance. As I mentioned earlier, now it is time to show you the billboard layer feature on the scene. Users can now insert the billboard or simplified LOD version of the original model for further reading distances in order to enhance performance and rendering distance for grass, where the original mesh is high poly and complex. This is vital for a dense environment with a lot of grass in the world. This is a flat terrain in another scene with the same grass scatter node in order to describe the billboard layer feature. If you pay attention to where the cursor is, you will notice that grass is shown in 2 different models. The model on the left side of the cursor is a more simplified version of the model on the right side of the cursor. The reason is, after a specific amount of distance from the camera, the simplified model is shown in order to increase performance. As I get closer, the high detailed model is shown instead of the one with less detail in the close proximity of the camera. And as I get farther away from that area, the model which is less detailed is shown again. The distance in which the simpler model and the detailed model are shown is also adjustable. In order to do this, select the grass layer from the hierarchy tab under Terrain section, and then head into Unity Inspector tab and then Model Type Settings. In Model Type Settings, there's a parameter which is called Billboard Start. If you decrease this parameter, it means that only the areas which are really close to the camera will have the high detailed model of the grass. And if you increase the parameter, the range which the high detailed model of the grass is shown is also increased. Now let's get to the next scatter, which is GPU instance scatter. This node places the models as GPU instances. We want to place a tree using this node, so we are going to select a tree prefab in this node. After selecting the prefab, I'm going to increase the placement distance a little bit. Placement distance specifies the distance between the placed models. In this case, it means that if a tree is placed the next tree is going to be placed 25 meters away. For placing trees and houses, don't forget to check horizontal rotation as well. GPU instance requires a mask. We are going to place this tree on our grass terrain layer, which grass is also scattered on it. So we are going to use the same mask which we used for our grass terrain layer and our grass scatter node. Again, let's click on the generate button in order to see the trees in the scene. Now that we've added the trees, let's add a couple of houses. In order to do this, we have to create the mask first. As you know, buildings are mostly placed on flat surfaces. So we are going to create a slope filter of 0 to 5 degrees. As soon as we create the slope filter, we are going to add the object to scatter from generator nodes. Object to scatter places normal prefabs in the scene with their transform references in the hierarchy tab, and it has the least performance compared to the other scatter nodes. In order to place the houses using the object to scatter node, first you have to assign the prefab. Now, as I mentioned, object to scatters have the least performance compared to the other scatters. So we are going to increase the placement distance in order to place fewer models on the scene to save performance. Just like trees, you have to check horizontal rotation option for houses as well. Now we just have to connect the mask which we created for the houses. Let's generate the world again in order to see the placed houses. The last to scatter node is tree scatter. We placed the tree using GPU instance to scatter earlier, and now we are going to place the tree using the tree scatter node. Again, we need to create a mask of the areas which the tree is going to be placed on. Let's say we want to place the trees on areas which are in the slope range of 35 to 60 degrees. In order to do this, we have to add a slope filter of 35 to 60 degrees. As soon as we create the mask, we add the tree scatter node. Tree scatter places vegetation models on the terrain, but unlike the other scatter nodes, it goes directly under terrain data. After assigning the prefab, all you have to do is connect the mask which we created for the tree and then generate the world again. This is our final scene, and all the layers which we created are under TerraWorld Terrain in the Hierarchy tab. And they can also be modified through Unity Inspector tab as well after selecting the desired layer. I hope you enjoyed the video. Feel free to ask any questions or give us your feedback in our Discord server. If you haven't already subscribed to our YouTube channel, don't forget to do it. Thank you very much and have fun.